Hello and thank you for watching my video. My name is Astrid Krasniqi. I'm CCNA and CCNP certified instructor. On this video we are covering CCNA semester 3 scaling networks, and this is chapter 8 EIGRP advanced configuration and troubleshooting. Now chapter 8 is divided in two sections. We have section 8.1 advanced EIGRP configuration and section 8.2 troubleshooting EIGRP. This is section 8.1 Advanced EIGRP Configuration. Upon completion of this section, you should be able to configure EIGRP automatic summarization, configure EIGRP manual summarization, configure router to propagate a default route on EIGRP network, modify EIGRP interface settings to improve network performance, as well as configure EIGRP authentication to ensure secure routing updates. Now this is the topology that we're going to configure, so you can pause the video, write down this topology, and this is what we're going to configure. First we need to do the router 1. So after configuring an IP address on each interface, as you can see there, G00, it's got that IP address, S00, that's description. It's better if you enter the description here as well. That's the interface connecting router 1 and router 2 with IP address 172.16.3.1. And then the interface connecting to router 3, 192.168.10.5. Then we went to the EIGRP configuration mod, router EIGRP1. This is a process ID that has to match on all EIGRP router, or signifies the autonomous system, AS number 1. EIGRP router ID 1.1.1.1. And then we advertise a network 172.16.0.0. This is a classful boundary, so anything that matches those two first octets, the first two octets, then is going to be part of the EIGRP. Now this command enables for us to send hello messages on those interfaces and as well as advertise that network. So this 172.16.0.0, the interface connecting towards G00, that matches because 172.16.1.0. and the interface, the serial 172.16.3.0 matches and towards router 2. Then we have a network 192.168.10.0, so that's the network that connects router 1 and router 3. So everything that is directly connected, we advertise it here. Do similar configuration on router 2. After we configure each IP address on each interface, then we go to the router EIGRP 1, so autonomous system 1. Router ID 2.EIGRP, router ID, router-ID 2.2.2.2. Then we have a network 172.16.0.0, so that matches the network towards router 1, the network that connects with router 1, and the network on G00. Then again 192.168.10.8, and here this time we're not advertising the class full boundary, but we are advertising class less. So 0.0.0.3, that matches the network between router 2 and router 3. Then on router 3, after configuring each interface with an IP address, we go to EIGRP configuration, router EIGRP autonomous system 1, give it router ID number, and then we enable in the class full boundary 192.168.1.0, that's a class C. Here, that's the address, and the network address on between the router 3 and router 1, 192.168.10.4, but that's classless. So for example, if you don't want to advertise this network in EIGRP, then you just don't enter this command. With the classless, you can do that. You can separate the networks that you do want to advertise and the networks that don't advertise if they are in the same classful boundary. The best way is to actually put the IP address of the router 3 and then just put the 4 zeros in the end. So you specifically advertise on each interface rather than like this, put it on the network. So I would type, for example, network 192.168.1.1 on this side, and then 4 zeros, 192.168.10.5, or sorry, 6, and then 4 zeros, 192.168.10.10, and then 4 zeros. That would be the best method to advertise. Automatic summarization. Now, router summarization is when you group a contiguous network together and advertise them as one. So for example, if you have a contiguous network, as you see on the screen, from 192.168.0.0 up to 192.168.255.0, all of them /24, you can advertise them as a single entry, 192.168.0.0/16. When you summarize networks, it's usually the subnet mask is going to be less to the subnet mask the networks that you're going to summarize. So for example, advertise them using a single summary route. The advantages of summarization is that it decreases the numbers of entries on the routing table. So instead of your routing table having all these entries and storing them in RAM, it will just have one entry, 192.168.0.0/16. Reduces the bandwidth utilization for routing updates. Instead of sending all these updates, these networks, 255 networks or 256 networks, you send them only one. And it results in a faster routing table lookups. Instead of routing table lookup for each entry, we just look at one entry. If that's a match, that's it. We do whatever it says, the next hop address. Now, automatic summarization is enabled for IPv4 only. In IPv6, it's classless, so we don't have automatic summarization. Automatic summarization, it will summarize all routes into classful boundary. So for example, remember we have class A, B, and C. These are the addresses, these are the ranges. So whatever this range, that we have three networks here, because this is 172.16, it falls on class B range. So we're gonna go and summarize it at the classful boundary, which is /16. EIGRP groups subnets into the class A, B, or C network's address and creates a single entry. So for example, router 1 is saying, okay, I'm running EIGRP for IPv4 and automatic summarization is being configured. So I'm going to send them as one entry. Summary update 172.16.0.0/16. So it's taking all these three networks and it's summarizing them at the classful boundary. And router 2 will add that on the table. Now later on we're going to see that this will cause some problems because here we are advertising quite a lot more networks that we actually have. We are advertising the 4, 5, 6 up to 255 we are advertising that we have, but we only have 3. So it does cause some problems. We'll see that fixed later on. Configuring EIGRP automatic summarization. Now by default, operating system 15.0 and above, automatic summarization has been disabled. And one of the operating system 12.2 really update 33. Before, automatic summarization was enabled by default with the command auto summary. So when we were explaining or teaching how to configure EIGRP, one of the first commands I used to tell my student is once you enable EIGRP, do no auto -summary to disable automatic summarization. So that's how you disable it. And that's how you enable it. So for example, we have router 3 is learning about all these three networks, 172.16.1.0, which is a network of router 1, 172.16.2.0, this is a LAN of router 2, and 172.16.3.0, which is the network between router 1 and router 2. And you can see that network, 172.16.3.0, it's load balancing. You can send 50% towards router 2 and another 50% of the packets towards router 1. To verify automatic summarization is enabled, we do show IP protocols, and when we run that command, that's going to tell us one of the entries there is going to say automatic summarization is enabled. So this is a default on the iOS prior to 15.0. For example, if you don't have automatic summarization, the router 3 will find out all the three networks as they are, so the subnet, like the subnets as well. With automatic summarization enabled, router 3 will see them as one network only, 172.16.0.0/16. Verifying auto summarization topology table, show IP EIGRP topology, all links. So we can see that router 3 has got the network 172.16.0.0 in passive mode and has chosen router 1 as a successor because it's a faster link towards router 1, and router 2 as a feasible successor or backup. So even if router 3 needs to send something to LAN of router 2, 172.16.2.0, it will send them towards successor first and then to the router 2. Router 2 might reply to like that, and that's something called suboptimal routing, where the packets actually taking the longer path to the destination. Summary route, example of routing loop. For example, imagine the router A has got a connection to the ISP, to the internet, and has created a default route towards ISP. That means catch-all, last resort is via ISP, which is 4 zeros, /0. Then it's going to update that's going to propagate our default route towards router B, and router B is going to enter that on the routing table. Now router B, imagine it's got these networks, 172.16.1.0, 2.0 and 3.0. Now router B is going to do the summarization and is going to send a class-full boundary summarized route of 172.16.0.0/16. Now router A will add that on the routing table and say, okay, well now if I need to send something to 172.16, I know it's router B. Now if a packet comes in, and the packet is for the destination 172.16.4.10. Now router A is going to look at the routing table, and that's going to be the first match. So 172.16 is a match. That's going to be, if that doesn't match, that will match everything else. But 172.16.4.0 or 4.10 matches this entry. And router A is going to say, okay, well, to get there, I need to send it to router B. So it sends it towards router B. Now router B is going to try and match all more specific match. So 172.16.4.10 doesn't match the 1.0, 2.0 doesn't match, 3.0 doesn't match, but it does match catch all, which is the default route. So router B will say, okay, well, it didn't match these, it matches my default route, so I'm going to send it to router A. Router A does the same process and send it to router B. Router B does the same process, send it back to router A, and then we have a routing loop. We have an interface called null zero. This is used for a loop prevention. So same scenario, router A has got connection to the ISP. It's got default route. Advertise that default route to router B. Router B puts it in the routing table, and router B's got these networks on its connected. Now it will advertise them as a summary route as before, but before it does that, it will create an interface called null zero that matches the summary route. This means that, okay, if it doesn't match whatever I'm summarizing, it will match my null zero, because the null zero is exactly what I'm summarizing. So router A will add that on the routing table, say, okay, well, like before, anything that starts with 172.16, I will send that to router B. Now a packet comes in for the same destination, 172.16.4.10. Router A will match this with this entry, and it will send it towards router B. Now router B will not be able to match all these three entries because they're different, but they will match more specific to this 172.16.00/16 via null zero. I have a summary route for 172.16.0.0/16 via null, so I will drop these packets. I will send them to the bin. So null zero summary routes, when we actually went to router 1 and do show IP route, we can see there we have summarized that entry, so 192.168.0.0. So all these three networks, 4.4.5 and .8, they are being summarized into one entry, and they created a null zero interface. So if a packet comes in for a destination that we don't have, it's going to match this summary route. So the purpose of null zero summary route is to prevent routing loops for destinations that are included in the summary but not actually exist in the routing table. So EIGRP for IPv4 manual route summarization. Manual summary routes. EIGRP manual summary routes used with or without automatic auto summary. EIGRP is classless routing protocol, includes a subnet mask in the routing updates. Manual summarization can include supernet routes. A supernet route is an aggregation of multiple major classful network addresses. EIGRP manual summarization is configured on specific EIGRP interface. And the command is IP summary-address EIGRP, then autonomous system number, the network address, and the subnet mask. Loopback added for demonstration. For example, on router 3 we have two loopbacks added, so 192.168.2.1, 192.168.3.1/24. So we advertise on those networks as well on EIGRP process. And then to verify it, we're going to see to router 1, go show IP route, and we are learning loopback 3, loopback 2, and the G00 interface from router 3. Same on router 2. So what we're going to do now, we're going to summarize these. So use the same method is used to determine summary static routes. So write out the networks to be summarized in a binary. Then find out the subnet mask for summarization. Start with the far left bit. Working from the left to the right, we find all the bits that match consecutively. For example, we write them on the binary, and we can see that 22 bits, they do match. They are exactly the same. So that will be our subnet mask. And then we say IP on the interface, summary-address, EIGRP1, and then the IP address 192.168.0.0, and then the subnet mask. So configuring EIGRP, calculate the summary route, and then go to the each interface, and we say IP address, IP, summary address, EIGRP1, process 1, then 192.168.0.0, and then the subnet mask, well, summarized subnet mask. To verify summary route received on router 1 and router 2, we do show IP route, and we can see that only the summary route has been received on router 1, and as well as on router 2. Note, a null 0 or null 0 summary route is being added to the router 3 routing table, but you can say it's not showing in here. EIGRP for IPv6 manual route summarization. So these are the networks that we can summarize on EIGRP, the loopbacks. Manual summarization can also be configured in IPv6, configured on specific EIGRP interface, like so, IPv6, summary-address, EIGRP, then autonomous system number, and then the prefix and the prefix length. To configure and verify an EIGRP manual summary route, propagating a default route. To propagate the default route, now imagine the router 2 has got a default route to the ISP. So what we're going to do in router 2, we add IP route 4 zeros, that means any network, space, now the 4 zeros, that means any subnet mask. We're going towards serial 010, which is our exit interface S010. Now, if we want to redistribute that route or that default route to our neighbors, we go to router EIGRP1 and say redistribute static. To create the default static route, that was the command. To propagate the default static route, we used to go to the EIGRP mode and we say redistribute static router configuration command. EIGRP also supports propagating the default route using the IP default -network and then network -number global configuration command, but this is not recommended. Our two default static route, as we can see that we have a default static route that says anything that comes, I can send it. If I don't match on my routing table, I can match like catch all or default route. Show IP protocols, that's going to say to us that we are redistributing the static route. And verifying that we have a default route on router 1 and router 3, we say show IP route, and we can see the gateway of last resort has been set, and we can see that we have a default route learned from external network, which is a static route, and that's going to get the administrative distance, as you can see there, of 170. Same for router 3. Has received that default route. Verifying the propagated default route, the entry for EIGRP learned default route is identified by the following. First, we have a D. This indicates that we have learned through EIGRP routing update. Star, the router is candidate for our default route. EX, the router is an external EIGRP route. In this case, a static route outside has been propagated to inside. And then the administrative distance is 170. That is for the external EIGRP routes. EIGRP for IPv6 default route. So for example, imagine the same topology, but router 2 has got default route towards the ISP. First, you need to configure that default route. That is how you configure IPv6 default route. Global config, IPv6 route, so static. : that means match any network. /0, that means any prefix. Go out of the exit interface serial 010. Then we go to the IPv6 router EIGRP autonomous system 2 and say the same thing, redistribute static. To verify it on router 1, for example, show IPv6 route, and we should see the external route that we have learned from router 2. Fine-tuning EIGRP interfaces. Now, by default, EIGRP is set to use 50% of the bandwidth of the interface exchanging routing information. To exchange routing information. So 50% of the bandwidth EIGRP could be using to exchange its own routing information like hello messages, updates, replies, and so on. Now, for that reason, that we need to make sure that we have the correct bandwidth on the interface. Because imagine that we left the default and that's 1544, but we only really have 64 kilobits per second. EIGRP could be using more than what we have for itself. So for that reason, we have to make sure that we correct the bandwidth that we have there. We can control how much bandwidth the EIGRP is using with the command IP bandwidth %% EIGRP command, or the IP bandwidth %% EIGRP command can be configured to control the amount of bandwidth available to EIGRP. This is not same as the bandwidth command. However, this command relies on the value set by bandwidth command. So for example, with this command, what we're doing here, we are correctly setting the bandwidth between router 1 and router 2. And we're saying that we should IP bandwidth %% EIGRP with autonomous system of 1 should be using 40% of the bandwidth only. And we have to do the same one for router 2. So in the interface, we correctly set the bandwidth, and we say that bandwidth, the EIGRP autonomous system 1 should be using 40% of the bandwidth for itself. If it needs to. It's not going to always cut and start using 40%. If it does need it, it's going to use up to 40%. For IPv6, the same thing. We just go and type IPv6, and the command is exactly the same as an IPv4. Hello and hold time intervals. So by default, remember the fast greater than 1.544 megabits per second. We send every 5 seconds the hellos, and the hold time is 15 seconds. 1.544 Mbps or slower, then the hellos are every 6 seconds, or the default hold time is 3 times that. If you want to change them, so hello in intervals and hold time do not have to match with the other EIGRP routers to establish these adjacencies. Different to the OSPF they have to match. OSPF hello and other timers, they do need to match between the neighbors. We can have the timers from 1 second up to 65,535. If you change the hello interval, make sure that you also change the hold time to value greater than the hello interval. Otherwise, the neighbor adjacency will go down after hold time expires and before the next hello interval. Configuring hello timers, you have to go to the interface. So interface serial 00, for example, IP hello -interval EIGRP 1 60. So we send hellos every 60 seconds, and then we configure the hold time 3 times of our hello. Same we do it on the router 3, for example. We change the hello time and the hold time as well. IPv6 is very similar to the configuration. It's just you have to put IPv6 and then hello interval EIGRP 2 /60 and sorry. IPv6 hello -interval EIGRP autonomous system 2, and we send hellos every 60 seconds, and our hold -time is every 180 seconds. Load balancing. Now routes with a metric equal to the minimum metric are installed in the routing table. Refer to is equal cost load balancing. So for example, if we have two or three paths, they are exactly the same as the fastest path, then we put them on the routing table and we do a load balancing. All IP routing protocols on a Cisco routers can perform equal cost load balancing. The maximum -path and then the maximum path command can be used to allow up to 6 equal cost paths. By default, we have 4 of them. So up to 4, we can load balance as long as they are equal cost. Now, EIGRP does support, for example, something called unequal cost load balancing. And that is if you change this variance. So for example, variance of 1, that's a default, that's a fastest link only. But if you have a variance of 2, that is 50% slower links, that will be enabled on our load balancing. That will cause unequal load balancing. If you change this maximum path to 1, we are disabling load balancing. So router 3 has equal cost paths to 172.16.3 3.0/30 because 64 kilobits is the slowest bandwidth used for the metric. So for example, when we do show IP route, EIGRP, we can see that router 3 has got 2 entries on the routing table, is doing a load balancing or equal cost load balancing. Load balancing IPv6, the same thing happens on the IPv6. We can load balance. Configuring and verifying EIGRP authentication. Now many routing protocols supports authentication. This means the router authenticates the source of each routing update packets that it receives. Without authentication, an attacker could introduce different or conflicting route information to corrupt the router, resulting in DOS attack or denial of service. So the network administrator must be aware that routers are at risk from attacks just as much as end user devices. Anyone with a packet sniffer, such as Wireshark, can read information propagating between routers. A method to protect routing information on the network is to authenticate routing protocols packets using MD5 algorithm. Routing protocols such as RIP version 2, EIGRP, OSPF, ISIS, and BGP all do support various forms of MD5 authentication. To enable EIGRP authentication, like MD5 authentication, the first thing that we have to do is create a keychain. And in that keychain, we can hang our keys. And each key will have its own password or its own string. And then we can call on that key. So before authentication is enabled, create a keychain and key. Multiple keys can be configured. Specify the key ID using the range of from 0 to 2,147,483,647. Recommended to use the same key number on all routers. So for example, and then we have to configure EIGRP authentication using keychains and key, and then enable EIGRP authentication on the interface and identify the keychain and key to be used. So specify the keychain that should be used for authentication. The keychain and the routing updates are processed using MD5 algorithm to produce a unique signature. So both sides we have the same key string. So we see the example here on the router 1. First, what we're doing, we're creating the keychain called EIGRP key, and in this chain we hang in key 1, and the key 1, the password of key 1 is Cisco123. That's by saying key-string Cisco123. We can see auto in global config keychain EIGRP1, and we enter the keychain configuration mode. Here we can create many keys, key 1, key 2, key 3, and so on. Then we take key 1, press enter. Now we are in the key 1 keychain configuration mode. And then we say key 1's, for example, is the string is Cisco123. So key-string 123 or Cisco123. Then we go to the interface that connected us towards router 2, and so we say IP authentication mode EIGRP1 MD5. That enables MD5 authentication. And then we say IP authentication keychain EIGRP1, then the name of the keychain EIGRP_key. Same we did for the interface S001. Exactly the same configuration we would do on the router 2 and router 3 as well. Well, similar configuration for router 3 as well. Now, the authentication, MD5 authentication, we can do it on IPv6 for IPv6 as well. EIGRP for IPv6. Same thing, we create the keychain, create our keys, create the strings as well for each key, and then we say IPv6 authentication mode EIGRP2. The command is exactly the same as IPv4, just IPv6 here in the front. To verify authentication, adjacencies are only formed when both connecting devices have authentication configured. So if one side has configured, the other doesn't, there's no adjacency. To verify the correct EIGRP adjacency were forms, we need to use the command show IP EIGRP neighbor. To verify the neighbor adjacencies for EIGRP for IPv6, we say show IPv6 EIGRP neighbor commands. For example, if we still have our neighbors, then our keychain and our authentication is working perfectly. Thank you very much for watching this section 8.1 Advanced EIGRP Configuration. Please have a look at the other videos and don't forget to subscribe. This has been Astrid Krasniqi. Next video, 8.2, troubleshooting EIGRP. Thank you and bye-bye.